I've been learning a lot lately that a lot of people have been using PEMDAS. And, there's kind of a problem with that, and, I'd like to go into it today. So it's just to go over the grade school thing, you got parentheses, you got, like, exponentiation, you got dividing, it's like that, you got multiplying, it's like that, you got addition, I'm just gonna write that like that, and you got subtraction, it's like yeah, you know all this stuff. But like, why do it in the PEMDAS order? Well, parentheses are there to denote, like, this is like an exception, basically. So if you have parentheses, you can literally, like, turn any expression into any other expression. 2 plus 3 times 5, right? If you put the parentheses there, it's not equal to 2 plus 3 times 5. And the thing is, the parentheses are implicit because you do multiplication before addition. So these are correct, quote unquote, just as a convention, and this is incorrect. But if you like this is not equal to 2 plus 3 times 5. This is not equal to that. That's a plus sign. And so implicitly, parentheses doing first, that makes the most sense. Exponentiation, that's like the growing fast one. The thing I have qualms with is why you do multiplication before division. And the reason that you should do division first is just because it's easier. Like, division and multiplication, they're literally the same thing. Like, if you're familiar with fractions, they're the same thing. Because, like, 5 over 3, that's just 5 times 1/3. PEMDAS, that's true. But the thing is, the difference between division and multiplication is because we divide things by integers. Or if not integers, usually things bigger than 1. Whereas with multiplication, we're usually multiplying by things greater than 1. And so they get a lot bigger, and things are a lot harder. Like, let's have a simple case. 88 over 44 times 3. Right. How would you do this multiplication? Well, of course you'd use a calculator, but what would you really do? So the thing is, 88 times 3 over 44. This is what this says. So if you're doing PEMDAS, the only logical thing you can do is 88 times 3, got 4, carry the 2, it's 4 again, carry the 2 again, but you got a 2 there, right? And you got 2 times, you already did the 2, use that, just, whatever, yeah, sure, it's 264, that's the answer. Doesn't really matter how, that's the answer. And then you do 44 taking away, and so, well, 2 doesn't go into 2 or 26, so you just gotta, I don't know, it's just, like, you can't do that in your head pretty easily. I mean, you can kind of see some stuff, you can like, well, if you multiply that by 5, 220 is obviously less than that, but still. The best way of actually doing things is much simpler. It would be to divide first, then multiply, because, well, 88 over 44, well, that's 2. You can just see that that's 2. So if you multiply, and then 2 times 3, that's 6. That's 6. So why is the rule that you would do it this way and then do this hard division when you can just divide first, get your tiny pathetic number, and then multiply it by 3? And heck, let's look at 88 times 3 to begin with. 88 times 3. The way that you would do it here is to just, like, multiply it out. Like, this way is stupid. It's stupid. If you do it this way, you're doing it the stupid way. You're not implicitly stupid. And even if you're bad at math, that doesn't mean you're stupid. You can be incredibly intelligent without being good at math. That's not what I'm saying. But what I'd do, looking at 88 times 3, is, well, there's a lot of 8s there. I don't know, there's 24 hours in a day, and I know that I divide my day into 3 equal 8-hour periods. That's how I schedule things. It's like, you got the night time, you got your morning time, and you got your afternoon, and you stick to that. You stick to 8-hour chunks. Anyway, or you could just know that. You could just know that 24 is 3 times 8. So, well, I know that fact, and I know that there's some 8s here. So the best thing actually to do here, if you're doing this in your head, is actually to multiply it by 8 over 8. And then you divide this 8 right here. So what you're doing here is you're multiplying this thing by 1 to make your life easier. So then you get 8 times 11 times 3. And if you want to be extra pedantic, we're going to actually change it to 11 times 8 times 3. And if you want to be extra pedantic, we should actually do it to 11 times 3 times 8, because I wrote it as 3 times 8 right there. And so now we're taking 11, multiplying it by 24. This you can do in your head, because it's just 24 plus, and you just take the 2, add 4, you get 6, right? And you got the 4 on its own, and you got the 2. So it's just, you add the 2 up to get the middle one, and then you just leave the 2 digits on the other side. That's what you're doing. So this is how you... So if this is PEMDAS is so easy that sometimes multiplying things by 1 ultimately makes things better, because you can just divide out all of the hard stuff. And it's just frustrating that people are using this ugly PEMDAS when they could just use the easier method. And it's just frustrating. So that's the whole video. I don't know why I got this piece of paper. I did. This is here. I draw a little smiley face on it. We did it. We can draw a box, because it's complete. We totally proved what we just proved. It's like, I showed that PEMDAS rules. Yeah. So this is just some celebratory paper right here to show all the work that we did right here. Because I think that proving that the way you've been doing math your entire life is wrong, I think that is some celebration paper worthy. Audrey out. Woo. Yeah.